Hi everyone, and welcome to today's webinar together with Datatonic and Keywordio. And we will speak a lot about promotion and dynamic pricing for e-commerce and retail. And we will also dig into some of the details about how to use machine learning today in a modern world. So first, happy to welcome you, Oliver, to this webinar. And please tell us a bit more about your background and what you're doing at Datatonic.
Thank you, Jonas. Very excited to be here. My name is Oliver Gindele. I'm Chief Innovation Officer at Datatonic. And in the past few years, I worked with a lot of clients in the UK and here in Sweden on implementing machine learning for retail and e-commerce specifically. So I'm going to share some insights and a case study actually we've done on dynamic delivery pricing for a retailer in the UK.
Great, I really look forward to that. And what I really like when I met people from Datatonic, I think it really stands out that you're really focusing on your core expertise, really try to build the best possible solution, use the latest technology in AI and machine learning. So this will be really interesting to look more into what insights you have to share. Mm-hmm. So to start off, I think it's also important because there is a lot of buzzwords and keywords within the area of AI and machine learning. So, for example, when I did my master's studies at engineering for like 15 years ago, I used neural networks for that. So it's been around for a long time. But I think it's important to clear out some of the areas. So well, please bring us through this slide and give us the high-level note on what AI is and what you see in it today.
Mm-hmm. Yeah, I think this diagram makes a good starting point for today's discussion to map out a bit what machine learning is and what artificial intelligence is. And as you said, there's a lot of buzzwords flying around in business context and boardrooms these days. But if you think a bit more simplistic, artificial intelligence is the field that tries to build thinking and smart machines that think alike humans or animals. Mm. And it's a very large field, existed for decades in the early days of computer science and computing. But within artificial intelligence, there's this big subfield called machine learning. And machine learning itself is concerned with making decisions based on data and finding patterns in data. So it's always coupled to learning and gaining experience from data and data sets, and then extracting that via algorithms. It's been a very successful field within artificial intelligence, but it's not all that artificial intelligence offers. So the AI field is a lot larger than machine learning. Interestingly, within ML, machine learning, there's a few subfields that have become very popular in the last decade. Predominantly the one called deep learning. And as I said, there's approaches called neural networks that mimic loosely how the human brain works. And neural networks are applied in deep learning, and this is where in the past 5 to 10 years we've seen striking success of machine learning systems in self-driving cars, in machine translation, in even recommender systems and computer vision. But also deep learning is not all there is to machine learning. There's other fields such as decision trees and probabilistic learning, and some of them blur a bit the boundaries of these fields and sometimes a bit academic definitions. But what I want you to take away from this slide is there is machine learning, but it's only a subfield of artificial intelligence. But in a lot of applications, this can be used synonymously.
Mm-hmm. Yeah, and also to fill out some more on that about like difference between Keywordio and Datatonic. Like you build a lot of solutions on top and using the tools and platforms you have in Google Cloud, and we build pretty much everything on top of Google Ads. And sometimes, of course, the tools coincide. You use data coming from Google Ads probably in a lot of projects.
Yes, definitely.
And sometimes we use parts of Google Cloud to implement our solutions as well. So I look forward to hear more about what you're going to share later. So the agenda for today, I will start off giving you some of the latest insights on how to work with promotions, how to do the analysis, and also looking into different examples of pricing analysis that you can do today based on Google Ads data. Then Oliver, you will go into more depth about like machine learning and how that is applicable in retail, and also some context and key trends. And then we'll end up with a really interesting example of dynamic delivering pricing, a feasibility study for that. So that's the agenda for today. So let's kick off with the promotion and pricing analysis. So when it comes to, I meet a lot of e-commerce companies today, and one question that I typically like to ask is really, what's your milk? What's your milk product? And in terms of what I mean with that question is really that, so for example, if you go into a grocery store, many people know what the cost for 1 liter milk is. And many times, I'm not saying that is the rational best thing to do, but many people actually judge the price perception based on what that milk costs, because that is pretty much the reference point that you have. And when you speak about promotions, many people think it's all about, okay, giving away margins, and I think it's just a really important area to do this smart, so you don't give away margin, but you actually do it to increase certain types of parameters, depending on what's important for your business at the moment. So just looking at, here are 7 different strategies for retail, how to run promotions. And of course, some of the most obvious ones are, okay, we give the customer a discount of 10, 15, 30%. Or should we give them a discount on an actual, like you get 10 euros in discount if you buy it. Or if you look into buy one, get one free, 2 for 1, there are a lot of different versions of how to use promotion. And of course, it's all about finding a way to trigger your potential customers to buy from you. And there's a lot of interesting data in this that you can learn from, and that you can do this a lot smarter compared to just saying, okay, let's run all the campaigns next month on 30% sales. Maybe you can have the same effect on 20% sale or a 15% sale, for example. So a couple of interesting parameters to evaluate about this. Of course, seasonality, both micro and macro trends. So the annual big trends and some of the local micro trends in terms of day of week, for example, could be really interesting. Doing analysis on category, brand, and individual product level, it's typically really important. And then, of course, look into what your competitors are doing and what is happening there. And of course, look into your own business, like what's your gross margin, what's the cost of sold goods, lifetime value, if you have a business model that actually you have a repeat purchase after the first purchase. Of course, that's a really interesting value to monitor. Or stock levels. Just make sure that, okay, is it about selling out the old stock or is it a new campaign, for example? So a couple of examples of macro trends that we think are really interesting. So for example, looking at the cost per click is really interesting if you do it on an aggregated level, just to look at some annual trends. And you can probably combine that with search volume or queries on Google to see, like, for example, here, if you see here that in September you have a spike in the queries for which happen to have the same time as the spike comes in cost per click. Probably means that there's a lot of people want to advertise in this area. But you can also find that, okay, maybe the cost per click is actually really low during 1 month. So when you're doing your annual plan, this is something you can probably include to see if you can get a lot more out of your advertising in January, for example. And how to plan for it if you have the big spikes that you really need to hit to make the result in the end of the year. Micro trends, that is more looking into what does it look like on a weekly level. So here, for example, if we look at Wednesday, we have the blue staple is return on ad spent or conversion value over cost. You see that you get like 8.4 times your money back, compared to some of the worst days in the week, like Tuesdays, you only get like 6.7 times your money back. And that is definitely something that could be used in a really good way when you're running small, short campaigns. You know, make sure to use your best days and experiment how to align that with when you run marketing emails, for example, as well. So what promotions should we run next month? We think that running promotions, it should be all about actually experimenting. So every time you run a promotion, you want to learn something about the consumer behavior that you have. So what can you learn, for example? Yeah, here, you know, if we're running ABC offer, then try to figure out these parameters. So you really see, okay, what is the volume, for example, on offer A compared to B? Like, how is people triggered by that? And really compare it to learn, for example, if you're speaking about discounts, then it's all about learning to be smarter on how to run discounts in the future. And why is price comparison not enough? I think this is a great example. So assume that you will have your phone and you will go in and search for a product. And 3 merchants show up. All of them are selling the same product. Merchant A has a price of 10 euros, merchant B has a price of 15 euros, and merchant C has a price of 20 euros, for example. Then what would the average price be if you go into a price comparison site? Then the average price would be 15 euros. If you're using this average price to think about how you promote your promotion or how to price your promotions, you're probably going to be quite off, because there's going to be very few people that click on the product that is actually just completely outpriced. So if you add a level of clicks here, then you can find something that is really interesting. The click weighted price, which is more like a marketing price. Mm-hmm. So this is actually what your customer think is more relevant. And you see here, the click weighted price is 11.3 euros compared to 15, which is a really big difference. And this is really important information that you should use when you think about promotions. And also about thinking about, well, should we even advertise for these products, for example, if we see that the price is too low, so we cannot make money on it. So think about this and make sure that you think about the click-weighted price and compare your promotion strategy with it. And also, Google Shopping is just a really powerful platform when it comes to testing these types of behavior, because you can be really fast and you can quite fast acquire data to learn what your users are triggered on. So for example here, if you're varying the price and you get quite fast data on what is working and what is not, that is really smart to use for future promotions as well. And like Oliver will speak more about later, as soon as you find these kind of patterns, then it probably makes sense to automate these kind of analysis, so you just can do them faster, and in the end completely let them run on an optimal level. So what does it typically look like if you look at a big assortment? So here, every dot in this picture is a product. The size of the bubble, that is the revenue on this product. And then you have on the y-axis, you have the benchmark product price. So that means that percentage, this product is priced compared to this click-weighted price. And then you have return on ad spend from Google Ads on the x-axis. So we have a couple of different clusters here that I think are interesting. So for example, the B segment. Assume that you would like to have a return on ad spend of about 8 and 9. Then you see, okay, here we have products that are actually cheaper than our competitors typically sell them for. So they're really good priced. We have a really low return on ad spend here. So there is something wrong. We have a best price on the market, but we're still not selling these products. So this is really something that I would like to dig into and learn, okay, why? And to make, maybe in the end, you will make sure that, okay, we should maybe kill these products, because, well, if we can't make a return on ad spend that is reasonable, even with a really good price, then maybe it doesn't make sense to spend money on this. Mm. In the C segment, here we have, for some of them, we have really good return on ad spend. and we have a competitive price. So here we have some good, really good products. And then in the A segment, this is also interesting because here we have a higher price compared to the market, but we are still being able to sell them for a good return on ad spend. And this is an interesting area to see if you can increase the size of these bubbles, because there's something with your brand that makes people buy this even if you have a higher price than the market. So then if we just zoom out and say, okay, let's take only the products that sell for more than $1,000, you see that the bubbles in the B sector, they are, it's not that many bubbles left. Most of them are still in the C, and yeah, there is not that much left in A. And if we take it even further, let's say that, look at 10,000 USD, for example, then you see there's only one bubble left in the B sector. Pretty much, yeah, all of the big ones are in C, and then nothing is left in A. And this is, yeah, good information that you can use to think about, okay, how can we automate to optimize the revenue here? And be really detailed all the way down to a product level, for example. And yeah, what it's all about? Yeah, of course, it is about trying to understand the price elasticity. Where are we pricing the products, and what's the actual revenue we are generating on that price point? And I would say very few examples are really linear, like in the school books. But trying to set experiments to test this and then keep iterating, that is really the key to solve this. And I see very few companies today being really data driven in how to set up these experiments on promotions and keep testing and testing to learn more and optimize for them. Now, of course, there's also other tests you can do, like bundle experience. See if you know, can you vary the size of the package? Can you vary the number, for example? This is also really cheap test you can do on Google Shopping, for example. Do 3, 5, 6 products, and then you can pretty fast see, okay, what type of bundle do your customers want to buy, for example. Or you can do like a summer package of different products and see, okay, this is actually something that really resonates with our customers. So just to summarize what we are doing at Keywordio, like I mentioned in the top, we build AI on top of Google Ads and custom made for e-commerce and retail companies to make sure that they can grow on their Google Ads channel. And we believe that the combination of human plus AI is really the way of the future, because there are a lot of things that is important to test and do the analysis and build a business case before you start implementing the full-on automated solution. So, for example, last year we made more than 93 million changes on our customers' Google Ads accounts, and of course that's going to be impossible to do if you work manually, which many companies do today. You can read more about this on Google's Think with Google blog, and Morten, one of our founders, he has a really interesting post about how we see the future within this area and how important it is to have the combination between human and AI in the future. And also finish up with a case. So we have been working with Three, the telco company in Sweden, and we have managed to go from quite like manual approach where a lot of man hour was put into the Google Ads account, and build a lot of data-driven processes to make it smarter and faster. And the results that we have managed to see on this is just, we're really proud to see the result with a great collaboration with Three. So we managed to increase the number of transactions with 50%, and we managed to lower the cost per order with 60% at the same time. And just looking at those numbers over the start, we were actually able to save 2.6 million with this case. So we're super happy about that, and it's a great example of what you can do with the power of automation and technology. So with that, I would like to hand over the word to you, Oliver.
Thanks, Jonas. Very impressive results. I think the numbers really speak for themselves, and I like your approach of just quickly going into an experimentation mode, and you showed very great examples of that. And I think this tactic of testing and learning and refining on the way, I think that seems to yield really good results.
Yeah.
And it's a way to increase automation, right, step by step as well, and build more trust as you go on the way. Great. I'm going to talk a little bit more about actually testing different machine learning models and strategies and the automation that brings. But maybe just, if you don't mind, a few words about Datatonic.
Of course.
We're a consultancy, boutique consultancy that in a nutshell does all things data on Google Cloud Platform. So we do data warehousing, business analytics and intelligence, and also machine learning. Sectors we predominantly work in are retail, media and telecommunications as well. I mean, you work a lot with Google Ads. We trust and build pretty much all of our solutions on top of Google Cloud Platform, and we've got a very good relationship with Google Cloud. And we've been very fortunate to be awarded with a few recognitions over the past few years. Most recently, we won Global AI and Machine Learning Partner of the Year award, which we're very proud of.
Yeah, I think those are really impressive awards that you have there.
Thanks. And beyond that, we also partner with Intel. There we work closely with Intel experts on making sure machine learning workloads run as fast as possible on the hardware. And we also work with Looker, who's offer a business intelligence platform that is very powerful and finds its way into a lot of our client projects. But I want to really talk a bit about some retail-specific use cases, and I'm just going to put it all out there on one slide, right? There's a lot of use cases here, but it gives a bit of view on how we see machine learning fit into the retail value chain. And there's a few different columns, a few different main sectors, and the first one is marketing that blends quite nicely into sales as well. And there's many use cases pretty much along the lines what you talked us through around the promotions, but it can also be about propensity to buy, lifetime value of customers, spotting specific trends or forming bundles of products. So machine learning and data can drive a lot of use cases there. And marketing and sales very interrelated here, especially you'll see this when we talk a bit more about pricing optimization. There's the operation side, which is really running your business and keeping the costs low. Machine learning has very traditional roots there in forecasting, but also optimization of processes such as, for example, delivery or routing. And then lastly, you want to connect with your customers, deliver great customer experience. So identifying unsatisfied customers and making sure that they see the right products at the right time and have a good interface with what they offer. That's the realm of the customer engagement. And there's plenty of use cases, and I think it's also a very proven area for machine learning in the retail sector. To really capitalize and activate on these use cases, you need to have some channels to really reach your audiences or to apply the use cases. And in marketing, it's predominantly ads, as we talked about. In sales, it can be a personalized offering or bringing a personalized price to the customer. On the operation side, it really is just optimizing potentially inventory, optimizing stock, but it can also be helping identify fraud, for example. And the customer engagement, there's a lot around the personalized experience on the web, especially recommender systems, maybe even in store, and identify and engage on a closer level with your customers and identify if they're really satisfied or not, and take the right next actions on that. But we're going to dive a little bit later on specific pricing optimization. It's also very closely related to promotions. And I'll give some examples of that in a few minutes. So I showed quite a few machine learning use cases on the previous slide, but you can simplify machine learning quite a lot if you think of it as there's only 3 tasks that machine learning does at a very high level. And there's first the prediction task, where a machine learning model will learn from data and then output the value. This could be numbers, could be a word, but you want this output to be as close to your input, to your target as possible. There's the task of self-description, self-describing, where you have an output, but this output should actually resemble the input somehow. So you want to find some patterns and maybe reshape your data a little bit. And then lastly, it's optimization. And optimization is pushing a specific KPI, a metric to the max. This could be return on ad spend. This could be revenue as general. It could be minimizing something like your cost per acquisition as well. And all three of these tasks are actually really useful across all the use cases I showed before, and they're going to find its way into pricing optimization as well, which I'm going to share in a few minutes. We can also describe them slightly different in more digestible words. The task of prediction is akin to educated guessing, right? I want to guess maybe and forecast a number, and then it's called regression, and that's seen often in demand forecasting. The self-description you often call clustering or segmentation, and it's very similar to what you showed before when you boxed different products depending on their return on ad spend and built segments and clusters a bit more manually, but there's algorithms that can do this at scale, very data driven, and you see a good example of that in customer segmentation, where you want to build audiences or group your customers that show potentially similar purchasing profiles.
Yeah, I think that's a great example of actually the example that I showed with promotion is really like a pre-study for the next step. And
absolutely, it's the analysis phase that then maybe or maybe not leads to a bit more automation as well, and an angle that machine learning might be able to take.
Yeah.
And then optimization is you want to improve your metric, right? There's decades of research and algorithms out there, a very old field of machine learning, and so it's a great way to apply it to the use cases such as pricing optimization and dynamic pricing.
Yeah.
Machine learning always needs data, right? You have this task of finding patterns in the data via algorithms. So looking very closely at the data and treating this with a lot of attention is something that we work very closely with our clients and draw a lot of benefit from. And what this means is we often focus on building out a single customer view that encompasses everything that your client interactions shows and displays. And this could be demographic information, this could be personal details, maybe some rule-based segmentations, interactions they leave with support channels, purchase history, etc. So gaining a holistic view of your customer is very important. And what you can then do is you can already transform this into something more proactive. You can use these data sets to train and build machine learning models that would do some segmentation automatically, maybe identify favorite products, have some forecasting ability, and then save this again in your data stores and build this actually proactively. And what this allows you to do is activate a lot of different use cases downstream. And examples of that would then be based on your segmentations and recommendations, you can personalize the web experience. And based on some clustering and trend spotting, you can apply demand forecasting. And again, pricing would be a channel to activate through here as well. But treating this single customer view as kind of an important treasure cove and something to build out this an approach we often take with our retail clients.
Definitely.
So let's say we identified a use case. It could be pricing optimization or dynamically creating promotion schemes. What kind of work goes into building a machine learning pipeline? There's a lot of steps involved, and it certainly starts with the data, with the raw data. So this could be the single customer view I just presented, but there might be other data sources that flow into this, more operational data sources, third-party data. Things such as weather information could be useful, right? Then the first few steps here are all around modifying and massaging the data. There should be steps of data cleaning to make sure that there's nothing polluting the data, no wrong values in simple terms. There's steps to do data transformations, feature engineering and feature selections, so to derive more complex views on your customer behavior. And once all these data wrangling tasks are done, you can start thinking about model selection. This is, you would apply some algorithms, this could be a neural network or a regression model, and maybe start very simple and train this on the data you have. And now we're looking at the blue dots here in this pipeline. And then validate it very quickly. Validate it on the historic data, validating through testing, go live, A/B test, and gather the results. And if you must, and it's very likely that you have to, go and refine, tweak your model parameters, collect more data, engineer more features, go back to the drawing board and improve your model step by step. And where you want to end up is hopefully all the way at the right hand side, where there's such a thing as a final model that you can then really put in production and run all the user traffic on. But there's a lot of steps that go towards that, and what this slide doesn't show is how much time you spend where. So I just want to give you a bit of insight there as well. And I'm sure this seems quite familiar when you think back to your master thesis. The expectation is often that you spend a bit of time on defining KPIs, you just gather the data, build some infrastructure to run your machine learning code, and then most time, 2/3, 3/4, you tweak the models, you and the team of smart data scientists will do the science and code these fancy algorithms, and at the end you have a model to implement. Reality, however, is that defining the KPIs might be easier than you think, because often they come very straightforwardly from the business. But you might spend a lot of time on collecting the data. This is because a lot of data is in data silos these days within businesses. Think back of this consolidated customer view I showed. Maybe some of the data needs to come from different business units, sits in different databases, sits in different countries. So bringing it all together is always a challenge. It's certainly a challenge where cloud can help as well. But gathering data is a massive act, and also all the steps around treating your data, cleaning it and defining features is where you spend a lot of time. Building infrastructure for machine learning workloads can also be time consuming, especially if you have a lot of data. Training these algorithms needs a lot of processing power. Again, this is where cloud can facilitate. But lastly, the integration part is often underestimated as well. So if you have a pricing strategy, you need to somehow implement this and roll this out. Or if you have on-site personalization, you need to speak, the data science team need to speak with your web development team to actually activate this and build this into the page. So there's some challenges there. But let's make this a bit more concrete and talk about pricing optimization. I think the use case, fortunately, is quite straightforward. I think it's clear to understand that the idea is to find an optimal price for each product, and this price could even be very dynamic depending on the time, and it could be personalized depending on the user behavior. So you want to understand when and how your customers purchase, but the goals will certainly be increased revenue and profitability, but also maybe leveling market access and making everyone able to purchase certain products. Of course, you don't necessarily need machine learning for that. There is many ways people have done this over the past decades to apply potentially rules, just hard-coded rules to this, or just a very strict and proven schedules of markdowns. Just have a summer sale where everything is 30% off. But machine learning can net a lot of benefits here. You can start with just predicting the outcome of a pricing strategy. What's the likelihood that this will actually work, or what's the expected return? You can bring in more short-term and more dynamic trend forecasting to respond very quickly to changes in markets. But mostly it can be a lot more granular here. And machine learning really opens up to being granular on the level of a product, so you can have a pricing strategy or set an optimized price per product and per customer. And that's a granularity scale that's not achievable with rules, because if you have millions of customers and tens of thousands of products, you won't be able to create manual rules for each of them. But with machine learning, you can really drill down and bring this granularity to a personalized point for each customer. On a high level, there's 3 ways to do pricing optimization. And the first one is you just look at your competitors. and as you showed, you can do a lot on price comparison and get a lot of information on how competitors price. There is also an interplay that if you maybe set a price, your competitors will do the same. It can lead to very interesting dynamics actually. We worked on a project with a energy firm and set prices for petrol stations, and there the pricing dynamics are quite complicated because there's a network of petrol stations over the countries that will all kind of look at what they do, which makes this an interesting and challenging problem. You can also take, as you explained, the more economic view and say, okay, we have some certain price elasticity and willingness to pay for each customer. So you can use machine learning to model that. And lastly, there's the time dynamics. You showed this very nicely as well. Ads might not cost, or clicks might not cost the same for you depending on the month of the year. And if you do own a car, you know maybe that petrol price in the mornings can be different from the evening when you return from work. Interestingly, all these approaches can also work together, right? It's not choosing one of them, and again, if you have the right data sources with machine learning, you can really combine them into one approach that sets a specific final price. Let's have a look at one case study that we've done with a retailer in the UK that sell all sorts of things, from home appliances to electronics. And interestingly, they see delivery pricing as one of their main profit drivers. So here we worked on dynamic pricing and price optimization for deliveries. And how this works is if you're a customer, you browse the page, you identify a few products you want, they go in your basket, and then you go to checkout, and you'll see a view as you see on that slide. So there is a pricing matrix, this display that just shows different delivery options, broken down by date and maybe even time of the day, and they all offer different prices. And now the challenge is, what's the optimal set of prices to suggest so that the user will actually go through with the purchase, that they're satisfied with finding the right time slot and having it delivered at the right time. And lastly, that the delivery profit and the delivery value is actually optimized and as high as it can be. And machine learning offers a lot of scope to really help with the problem. And I'm going to break this down a little bit. So to tackle this, we looked at two different contexts. And one is the purchasing context, and that's around modeling things like willingness to pay. So we put and learned machine learning models trained on historic data that would identify and predict the sensitivity, the price sensitivity of each customer and their willingness to pay. So that's the elasticity. We also had further models to predict the preferred time slots, whether someone would be likely to choose free or paid delivery. And it also depends very much on what they have in their basket. So if you think you buy just a small item, a cable for your TV, maybe you don't quite care when it arrives, and free delivery seems appropriate because the item's cheap. But if your fridge freezer combination breaks now in summer and you need urgently a new one, you're probably willing to pay a lot more for delivery because you want to be home when it arrives, and you might want to have it as soon as possible or on a day you're off work. So having the opportunity to pay more, but also having a more timely and more precise delivery might be in your favor. So that's an opportunity to then increase the delivery price.
Actually, that case just happened to me, and I really wanted to get it done as fast as possible, and when I knew I was home. So it's a good example. Yeah. It's spot on.
Interesting. And we didn't even rehearse this.
So
no. Yes, but I do think it makes sense, and that's really where a data source such as browsing history can also help, where you might see if you target specifically search for this item, maybe you really need it, and you probably be willing to pay a little bit more. And if someone is just casually browsing and putting things in their basket, online window shopping, so to say, maybe a free delivery is more appropriate on certain dates.
Yeah, but my behavior was definitely just I knew exactly what I wanted, and I just wanted it, really high intent. This is definitely a pattern you will be able to pick up quite fast, I would say.
Certainly, and we definitely found a lot of traces in the data around that.
Mm.
There's also some predefined segmentations and data that comes in, and customer segment and their loyalty to brands, for example, and plays a role here. And not to forget, the business context matters to make this suggestion of prices as well. So all this factors in, things like stock availability, delivery capacity, into machine learning model that would then, for each checkout, for each user, present a few suggested prices. Speaking of the data though, it's important to find these patterns as you described and see that there's variance in the data. Right? You want to do the analysis first, and we've done this on many different levels when we started this project. And one thing we looked at is, for example, does the location matter? Do people in different regions pay differently on average for their deliveries? And you see this in the UK, yes, that's the case. People in the cities tend to spend a bit more on deliveries. You can also have a breakdown without showing actual numbers on the order value per date. And you see for free delivery that kind of peaks midweek, but if you look at paid delivery, it's a different story and it shifts to weekends. So there's a lot of variance, and there's clearly some indications in the data that a machine learning model can pick up and maybe suggest a price that's slightly more refined and better and optimized versus some rules. So how this looks like if you put it together and then engineer features on top is an example of the features and data sources that came into play in this dynamic pricing model. And there is product related ones such as the weight, the size, categories, but also is it a premium product? If you purchase a very premium type of product, you might also be more inclined to pay more for delivery. There's order related features of course as well, number of units, when the order's been placed, but also holidays, things like the holiday flag mattered a lot. Black Friday, Christmas, there are periods where things can go quite extreme, so marking this specifically in the data is a useful approach here. And then lastly there's this single customer view again, the customer related data. This could be where they live, their browsing history, brand loyalty, etc. So all this will come together in a flow that looks a bit like described here. So we have customers and they will place orders, and they also have some demographic information and data, and they will all flow into a machine learning model that does multiple things. So there's actually multiple models under the hood. So it would predict and estimate willingness to pay, likelihood for free versus paid delivery, preferred time of the day, all these things, and then make a final suggestion for the prices on top of that. But what's very easy for technical minded people, data scientists like myself, is to forget about the business and just you want to tweak the machine learning model and only look at the data, but you can't keep the business out of the loop. No. And two examples here are first the delivery capacity. Right, if you set the price on a specific time slot very low for multiple customers, they will want a lot of deliveries and you might run out of trucks, so you can't deliver anything anymore. The other way around works obviously as well. So there's a strong interplay with the price you set for the delivery versus what you have in terms of trucks on the road, similar to price and inventory in a product scenario. And the same is true with business rules. So your pricing model will suggest some prices, but the customer might actually not go through, might not even convert, might just drop off. But if they convert, you might want to loop back to adjust this. Maybe your conversion with a given model drops too much, so you want to adjust a few parameters, and you want to give your business the opportunity to interact with the pricing model and take in modifications. Maybe Black Friday is coming up and you really want to overrule the model or switch it off completely. So having this feedback loop with business rules is quite important as well. Or maybe you want to run a specific promotion or a specific campaign, and then the machine learning model doesn't have any data on that yet, so you want to overrule this as well. We now looked at the data and the workflow. if you build the machine learning pipeline, as described before, you need to execute this somehow, and we always choose Google Cloud for that, and it offers some great tools. There's a great stack to do analytics such as BigQuery. There's all the storage and compute options, and there's many services, easy to use, fully managed by Google Cloud, to also do machine learning training at scale and inference, and this is AI platform or ML engine. So this use case was built on Google Cloud Platform, and to put it all together, this is the service we actually built with the client. We predominantly do project-based work, but here we actually offer the service for our clients, an API, that when a user goes now to the delivery checkout page and they see this pricing matrix, or even before they see this, they will make a call and their web backend will call our API, and we send back suggested prices. This happens in real time within, I think, 50 milliseconds, and then the client can populate their pricing matrix for the users to see. Of course, as I explained, there needs to be a connection, a plug to the data backend to get in capacity on deliveries. We're not going to suggest the time slot where there's no deliveries, or if there's items not in stock, etc. So we need to connect to the business. And it also happens on the other level where pricing analysts need to have an interface where they can adjust parameters of the models and take on manual control. And again, this was built completely in Google Cloud Platform. But bear in mind, this wasn't a one-shot project either. As you said, experimentation is key. And here we start with a few simple models and put them into action and into testing mode very quickly, and then run A/B tests to really identify what's the right set of models, what's the right parameters of these models to interplay, and then quickly iterate to find something that yields as much revenue optimization as possible. And what we really achieved here is we could increase the average order value significantly. So we could increase the delivery revenue by about 10%, while actually only minimally impacting conversion rates. So there was a massive uplift for the client there, and this was achieved through building these multiple machine learning models that would then make this final price suggestion, and it accounts for the purchasing context, the user-based, and also the business context, and allows our clients to really fine-tune and tweak the parameters of the solution over time. So this was to wrap up the dynamic pricing for deliveries we've developed, but I think we have plenty of time for questions as well.
Yeah, I think it is a great case, and I also like the way, like we spoke about also, that it is definitely not one shot. Okay, solve everything with a big AI model that solves everything. It's a lot of smart people involved that has done a lot of analysis to come to this result as well, and then of course maintaining and improving as well. So yeah, great example. But I have some interesting questions to you. So for example, what do you see as the biggest challenge with machine learning today?
I think one of the biggest challenges is putting machine learning models into production and actually closing the loop, as I explained it, with the business. Often, from experience, you can, if you have the data, you can build the machine learning models within a week or two, which is really accurate and does a great job. But then you might spend months or years to actually implement this, because you need to bridge different parts of the business, and it's not straightforward to see how the predictions actually reach the users. So in the case of dynamic delivery pricing, we spend a lot of research time on developing the models, but we probably spend a lot more time on working with their web team to actually make sure that the solution can be integrated. So I think there's a lot of blockers to quickly roll out and productionize machine learning models these days, and they're not necessarily technical, they're more related to making the right connection within the businesses.
Yeah, and I think also, like what you said about the expectations from the customer side, like people, of course, if you have a key role at the customer, it's it's seldom that you have time to actually emerge in the details and actually have the right expectations as well. Of course, you and the team at Datatonic, you spend only time on that, right? So it's of course it's different. But I'm also interested, like, where do you find the latest trends and technology when it comes to AI and machine learning? What sources do you go to and what do you look for?
I think myself and the team, we all have a bit our preferred sources. I think that's quite personal. There's certainly a lot we just draw from the academic literature, especially with the field of machine learning is great because very little is paywalled, as in you don't have to pay. So there's great tech blogs by some of the major players and corporations. I mean the fangs of the world. They release a lot of information. To really have the most up to date, I think I like Twitter and Reddit a lot. Very easy to consume, and there's a lot of the conversation is also where the conversation happens. Lastly, I think within the team we also just have some healthy discussions on our internal channels. We have a weekly catch up with the machine learning team to just discuss ideas. Say, hey, have you seen this new framework? Have you seen this new paper? And we of course also go a lot to conferences to contribute, but also to learn and network. So there's a bit of mix of things to get the newest and latest. But I think coming from academia and a more physics background, machine learning is amazing. The whole field of data, because so much lives in the public domain and is accessible.
And one thing that I see is really great also with it is that I see that there's a lot of the big companies that spend a lot of time, money to actually make it more accessible as well. Like for example, looking at how to implement and test models with TensorFlow, for example, the accessibility on that is just really, really great, I think. And you don't need to be like a really skilled developer to actually start playing around with some of these basic machine learning models as well. And that is something that I think is great and will be really important for the future. So make it more accessible.
Yes, fully agree. The only challenge is the speed, right, at which things develop these days. New tool sets coming out, new research, new papers. So it will probably take more and more effort to stay up to date. But I think that's also where the fun is.
Yeah, definitely. And I also saw that you, for example, on one of the slides you had with marketing, sales, and then operation and engagement. So where do you see you spend the most of time from like Datatonic perspective? Like where do you have the most of your projects running right now in that?
So in terms of time, or actual project spend, is probably marketing and sales. But also customer experience. We work a lot on recommender systems and a matching of products and users. These are all also the very, let's call it obvious and low-hanging fruit use cases for a lot of especially e-commerce and pure online players, because the data is there. They're fairly straightforward to implement, and the expectation set is quite clear. So these use cases are actually probably where we spend most of our time.
And one thing that we see is that of course a lot of people speak about big data and it's easy to get a lot of data, but I see one of the big challenges is actually small data, because like if you have a big data set, you have a lot of products, you have a lot of conversions every day, but when you start digging into some of the details, for example segment on age and gender, and then you segment even into postcodes and certain types of behavior, even some of the biggest companies have limited amount of data. Like what do you see in that space when you don't really have enough data to actually make the best suggestions?
Yeah, that's a very, very good question. It's certainly on our mind a lot. I mean, generally speaking, and I think there's even a famous saying by someone, all big data is actually small data, because once you start slicing and dicing, and you always end up with only a few examples per gender bracket or something. You absolutely spot on, and that makes it difficult to be very predictive on that granularity. I think one approach, you can always just say, do we need that precision? Right? Just say, all right, do we actually need to be super predictive on a personal level? Or can we say, no, it's enough if we build very sharp groups or audiences? Or do we need to predict for the next second, or is it enough to predict for the next hour?
Mm.
So one approach might just be to challenge the assumption that you might need to be on that granularity. If you really have to, then there is actually a growing field and movement to look into small data methods to really make machine learning work with as few examples as possible.
Yeah.
There's two interesting directions. One is to basically train a machine learning model on where you have a lot of data, and then taking parts of that algorithm that's now trained and has the information, the patterns encapsulated, taking that and applying it to your small data, and you might have retained something that's useful even for that small data. That's called transfer learning, and that might be one way to tackle that. And another way is just using very explicit approaches that are known and targeted to do well on a few data points. And Bayesian approaches come to mind here. There's whole frameworks and mathematical theory around actually making as good as prediction as you can with as few data points as possible. So there's ways to deal with small data. I would always suggest look closely first. Do you have to deal with small data, or can you just say no? Let's relax this a little bit. If yes, there is also some very interesting technical and algorithmical approaches to help with that.
Yeah, and I also think that even if today we have the computer power we have today was like going 10 years back, it is insane, the development. But even with all the computer power we have today, of course you need to be smart. But what computations you make, because it's easy to create a lot of unnecessary data as well, right?
Definitely, yes. It's also very tempting. Because you can, right? And then you get your cloud bill at the end of the month, and you might want to reconsider. Yeah,
exactly. And also short-term trends. It's also a challenge, like certain events that happens, or so. So how do you think about that?
Yeah, it's a good question. Modeling very short-term behavior, I think actually kind of is related to the small data problem, because if there's extreme small short events like holidays, Christmas, or the past few months maybe, it's very difficult to predict these things. Again, I think there's some pragmatic business approaches to just say, can we ignore this? Or if a holiday period approaches like Black Friday with this dynamic delivery pricing model, we probably wouldn't trust the model that's trained on the historic data and say, no, we'll tune it down for the time being. So that's kind of the easy way. But the other way is also to just tweak the models and gear them to be very sensitive on maybe short-term movements, which can maybe pay off badly in other scenarios. But I think there's ways to make sure that you can capture very, very short-term spikes and signals as well. But I mean, actually, question also back to you and how you think this will factor in doing promotions.
Yeah, I think really it's being better on forecasting. I think that's really important. Being better on forecasting with very small amount of data and looking at like typical. We speak about top funnel metrics. So can you make smart predictions with click-through rates on a Google Shopping campaign, for example? Because that is something that is very cheap to collect, and if you can say smart things about that in terms of how your promotion is going to perform, of course, then you will probably be able to say really good things maybe 1 or 2 days into every new promotion, which is going to be a really powerful tool, because maybe you should change the promotion, or you should extend the length of it, or you can do a lot of interesting things there. So I think there's a lot of work that needs to be done in the forecasting and using top funnel metrics to predict quick changing behavior. So I think that's an interesting space that we're going to see a lot more in.
Yeah, I can imagine.
Yeah. Great, but thank you very much for tuning in for today, and thank you very much, Oliver, for joining.
Thanks for having me.
Thanks.